a three variable function. A three variable function f from R3 to R. The domain will be subset of R3 and the output will be again a real number. Is a rule that assigns unique real number W in R to each order triple x, y, z in the domain D. So let us say this f is function from D to R and where D is subset of R3. So now we define a function from R3 to R, D which is subset of R3 to R. Now what will be graph? Graph of f will be collection of points x, y, z, w in R3 cross R and R4 such that w is equal to f of x comma y comma z. What is x comma y comma z? It is element of the domain D. And now it is very difficult for us to draw a graph of this function into R4, as this graph will be subset of R3 cross R. And if the domain is R3, now if we apply the same concept of as that of the level curve of two variable function to here for three variable function, so in the domain the set of points which will be at height z equal to k or f of xy equal to k. So here if we see something like this, so what will be the collection of points? Those are lifted to height f of xyz equal to k. So here it will not be a curve. Here it will be a surface in R3. So it is beneficial for us. For why? Because we cannot draw graph in R4. So if we want to study the graphs of three variable function, so we can study them from their level surfaces. What happens to these graphs in their domain? What are those points which are going to the height f of x, y, z equal to k? So we can study like this, by this way. So the level surfaces of three variable functions. So a level surface of a three variable function f from D to R, where D is subset of R3 of a three variable function f is a surface in domain D, which is subset of R3, is a surface in domain D, and is given by the equation this k is height, where k is constant, and this k is from range of f. Okay, f equal to k or w equal to k. So let us see some examples to find the domain and the level surfaces of the three variable function. So, example 1, find the domain. The function is f of xyz equal to ln of z minus y plus x1 into sin z. So this is three variable function. So what should be the domain? The definition of function is same. So what should be there in the domain? For which points in the input, set of inputs we are getting output, those points of the input set will be in the domain of f. So here, what are those points which will not provide the output? That means in which case we are not getting the output. Which are those points problematic? Here it is logarithmic function, so it does not give the value or does not give the output if the input is 0 or negative number. Sin z, it gives output for any real number x into y, no problem. So problem is with this logarithm of z minus y, ln of z minus y. So if this quantity is negative or 0, so we should not get the output. Therefore, f of xyz will not define if this z minus y is negative or equal to 0. That means what we should want? We should have this quantity should be positive. It should not be 0, it should not be negative. Therefore, domain of f will be collection of elements in R3 for which z minus y should be positive. So simplify this, it means collection of points in R3 such that z is greater than y. So what are those points? Z is greater for which z is greater than y. So in R3 we have 8 quadrants, 4 quadrants in upper half part, that means along positive z axis, and 4 parts are below that xy plane along negative z axis. So for this we need to draw the graph of, we need to at least visualize what will be the plane z equal to y, and then we have to differentiate the two parts, in which part x is less, in which part z is less than y, and in which part z is greater than y. So geometrically is a domain of f. Now it's your job to visualize the surface z equal to y and the two divisions where z is less than y and z is greater than y. So it will be the plane y equal to z passing between the two axes y and z through origin, when the y coordinate will be same as z coordinate. Y and z coordinate are fixed, x coordinate may vary. So try to visualize. The next example. The second example is f of x, y, z equal to root x plus root y plus root z plus ln of 4 minus x square minus y square minus z square. Evaluate f of 1, 1, 5 and describe domain of f. Okay. So let us find f of 1, 1, 1. So this square root 1 plus square root 1 plus square root 1 plus ln of 4 minus 1 square minus 1 square minus 1 square. So it is 1 plus 1 plus 1 plus ln of 4 minus 1 minus 1 minus 1, so minus 1. So ln of 1 is 0 and the value of f of 1, 1 is 3. Now we have to find the domain. So f of x, y, z is root x plus root y plus root z plus ln of 4 minus x square minus y square minus z square is, in which case this function will be not defined. Not defined if x, y, z are negative and when these quantities inside the square root are negative, in this case also, and if the quantity under this function logarithm will be 0 or negative. 4 minus x square minus y square minus z square, this quantity is negative or equal to 0. Therefore, what should be there in the domain of function? So it should contain the points in R4 such that it is domain. So it should contain such points in R3 for which x, y, z should be either positive or equal to 0 and 4 minus x square minus y square minus z square should be positive. It means what? Should be collection of order triples from R3 such that x, y, z, all the three are non-negative, that means greater or equal 0, and x square minus plus y square plus z square should be less than 4. So geometrically, what is it means what? So what is it? X square plus y square plus z square equal to 4. That means equal to 2 square. So it is sphere of radius 2. Right? So what will be part of the sphere for which x is positive, y is positive, z is positive or equal to 0? So it will be a region in first octave region in first octave part of sphere in first octave where x is positive, y is positive, z is positive, but it does not contain the boundary of the sphere. That means this outer surface should not be there. Right? Inner part. So his boundary should not be there. Even his upper surface is not there. Right? Simple. G is function from R3 to R given by G of x, y, z equal to x cube y square z into under root 10 minus x minus y minus z. Then evaluate G of 1, 2, 3 and find and describe domain. Okay, solution. So g of x, y, z, is it a function defined everywhere from R3? No. X cube y square z algebraic function, so no problem with them. So under root square root is there, so we have problem with that. So the quantity inside the square root should not be negative. It can 0, it should not be negative. So it is not defined if when it is not defined 10 minus x minus y minus z is negative. Therefore domain should be what? Domain should contain those points of R3 for which 10 minus x minus y minus z should be greater than equal to 0. That is, those points such that x plus y plus z less equal to 10. So what are those points? X plus y plus z less equal to 10. Try to visualize. What are those points? In plane R3 for which x plus y plus z less equal to 10. So draw this plane in R3. So this is the plane which cut the coordinate axis at 10, 0, 0, 0, 10, 0, 0, 0, 10. So 10, 0, 0, 0, 0, 10, 0, 0, 0, 10. So this is the plane. So this plane makes two parts of R3, above this plane and backside of this plane. So for which part decide? Check for which part x plus y plus z is less equal to 0. Okay. I think to the backside of this plane, these are the elements because if I choose the point next to this 0, 11, 0, so x plus y plus z is not less than 10, it is greater than 10, 11. So if I choose this point 0, origin 0 plus 0 plus 0 is 0, which is less than 10, right? Next example. Find level surfaces of function f from R3 to R given by f of x, y, z equal to x square plus y square plus z square. So f is function from R3 to R given by s f equal to x square plus y square plus z square. It is very difficult to draw the graph in R4. So what will be the level curve of this function, level surface? So let k is a real number which is from a range of f, which is from range of f. Therefore x, y, z equal to k. That means x square plus y square plus a square z square is equal to k. So this is nothing but equation of sphere with radius root k. So this is nothing but family of spheres if I vary value of k equal to 0, k equal to 1, k equal to 2. So this is everything, the family of spheres. So it will be small sphere, then big sphere, then some big sphere, then so I have drawn the graph of sphere inside sphere. So I will show you. So okay. So we have seen the definitions of 2 variable and 3 variable functions. We have seen the graphs, how to draw their graphs, their domains, their range, and the level curves and level surfaces. So it is very difficult for us to draw graph of difficult functions in 3-dimensional space or 4-dimensional space. So I have plotted some graphs to show you. So let us see. So there are functions which are very difficult to write, but their graphs are so beautiful, and you yourself can also try at your home in the mobile by using computer also. Just go to Google or plot 3D graph or 3D drawing. You can enter the function and you can see how the graph look like. So thank you. Let us. We have seen the definition of function of 2 variables, their graphs, that means surfaces, and their level curves in the domain. So see here the domain of the function would be the subset of xy plane, and the graph of the function will be in 3-dimensional space in R3. So this is the blue sketch is the graph of function f, graph of 2 variable function f, and see there are lines drawn on the surfaces. So these lines are called as contours on the surface. So these are nothing but the level curves of function f. And see, these contours are also drawn in the domain. So these are corresponding curves in the domain which are shifted to or lifted to height z equal to k. So these curves in the domain are called level curves of the surface, level curves of the function. So see, these are the curves, the level curves for k equal to 45, k equal to 40, k equal to 35, k equal to 30, k equal to 25 and k equal to 20. So these are level curves for this surface for different fixed values of k. So these curves from the domain are lifted to some height z equal to k, and these are actually the curves from the surface. So let us see some other graphs. So this is a graph of 4x square plus y square plus 1, and see, the surface will be elliptic paraboloid along positive z axis because image of the function is positive. And see, the graph is lifted by distance 1. This is because it is 4x square plus y square plus 1. And in the domain of function f, the level curves are ellipses in xy plane. The next surface is z equal to x square plus y square, which is paraboloid, and the level curves are circles in xy plane. The next one is f equal to square root of x square plus y square. So the surface is cone, and again the level curves will be circles in the domain. Next one is z equal to cube root of x square plus y square. In this case also the level curves will be circles in domain which are centered at origin. The next one is graph of function z equal to x and z equal to y. So first graph z equal to x is nothing but it is a linear function which is plane x minus z equal to 0 or z equal to x. So it is plane. So it consists all those points in R3 for which the x coordinate and the z coordinate are same. So it is plane passing through origin. The next one is z equal to y. So it is also a plane passing through origin, and it collects all the points in R3 for which y coordinate is same as z coordinate. Try to find out the level curves for these two graphs. The next function is z equal to 1 plus x plus y. So it is again equation of plane. It is again a plane which is passing through the coordinate axis. So see the graph and the level curves of this plane will be lines in the domain. The next one is also a plane z equal to 10 minus x minus y. So try to draw this graph which is also intersects all the three coordinate axes, and again the level curves would be lines in domain. The next graph is z equal to x square plus y square plus 5. So we have seen the graph of z equal to x square plus y square. In this case it is plus 5, that means the graph of z equal to x square plus y square will be lifted by distance 5 in upward direction, and in this case also the level curves will be circles centered at origin. The next one is z equal to x square plus y square minus 5. So what will be the effect of this minus 5? Our paraboloid x square plus y square will be lifted by distance 5 in downward direction along negative z axis. So what will be the level curves? The level curves would be again circles. The next is z equal to minus of x square plus y square. So as that of the graph of x square plus y square, it is along positive z axis. So in this case, all the values of z, all the values of function are getting negative. So our graph which is along positive z axis have to flip in downward direction along negative z axis. So this is the paraboloid in downward direction. The next one is z equal to 5 minus x square plus y square. So the paraboloid in the downward direction, here it is plus 5. So this downward direction paraboloid have to lift in upward direction by distance 5 unit. The next one is z equal to 10x square plus y square. It is elliptic paraboloid in upward direction. So the level curves of this function or this surface will be ellipses in the xy plane. The next one is z equal to x minus 50 square plus y plus 50 square. So it will be again a paraboloid but situated somewhere at a different point. So it is situated at 50 comma minus 50, and the level curves will be also a circle, but these level curves will be centered at 50 comma minus 50. Yeah, this is the graph of this elliptic paraboloid, which is lifted to distance to height 1 unit in upward direction. The next one is half spheres along positive z-axis and negative z-axis. In first, z equal to square root of positive square root of 9 minus x square minus y square. So all the values of z are positive. So it is upper half sphere which is along positive z-axis. And the second one is z equal to minus of square root 9 minus x square minus y square. So it is lower half sphere in along negative z-axis. So in this case, second case, all the values of z are negative. In first case, all the values of z is positive. That's why both the surfaces are along two different regions, along positive z-axis and along negative z-axis. The next one is graph of, it is full sphere, z square equal to 9 minus x square minus y square. So try to find out what will be the level curves for these spheres. The next one is cylinder. So the first one is graph of cylinder, x square plus y square equal to 4, and z varies from minus infinity to plus infinity. So what will be the level curve for this graph? Try to find out for different value of k. The next one is y square plus z square equal to 9. So it is a cylinder along x-axis. The red axis is x-axis, the green axis is y-axis, and the blue axis is z-axis. So the second one is cylinder along x-axis. X is varying from minus infinity to plus infinity. So try to find out what will be the level curve for this graph. For third one also, please try to find out what are the level curves. These are also cylinders, x plus 5 square plus z plus 2 square equal to 9. So it is cylinder and y varies from minus infinity to plus infinity. So try to find out what will be the level curves for both these graphs, both these surfaces. The next one are surfaces z equal to x square along positive z axis, z equal to minus x square along negative z axis. So try to find out the level curves for different value of k. Z equal to y square, z equal to minus y square, x equal to y square, x equal to minus y square. Next is x equal to z square, x equal to minus z square. So observe these surfaces. Then y equal to x square, y equal to minus x square in 3-dimensional. The next, y equal to z square, y equal to minus z square. So try to find out try to sketch the level curves for all these graphs. The next is z equal to x square plus y square upon x plus y. Observe that this function will be not defined when the denominator becomes 0. In the numerator it is algebraic function, so a polynomial function, it is defined everywhere in the domain, that means in R2. But in the denominator, if the denominator becomes 0, the function will be not defined. So it will be not defined if y is equal to minus x. So try to visualize where is y equal to minus x, and in that part, in that For this case, we will not have any surface for the function. The next is x square plus y square upon x square minus y square. So in the numerator it is well defined function in R2, but in the denominator it may be 0 somewhere. So where it becomes 0 if y is plus or minus x in this case. So observe that if y equal to x and if y equal to minus x, we are not getting any output for function f. The next is graph of z equal to 1 upon x minus y. So denominator will be 0 if y equal to x. So function will be not defined and we may not get any surface for these points when y equal to x. The next is z equal to square root of x square minus y square. So we have drawn the domain of this function. So the function will be defined if the quantity inside the square root will be 0 or positive. So will be domain if the points in the domain will be collection of x, y, for which x square minus y square will be greater equal 0. So try to simplify and observe how the graph can be sketched. Next is function 1 upon square root of x square minus y square. So here the two conditions would be there. One is there is a square root and the second one is the square root is in the denominator. So the denominator should be non-zero and the quantity inside the square root should be positive. So we will get the graph in upper half part and we will not get the we will get our graph if x square minus y square is positive. So x square greater than y square. So what is the region? What will be the domain? So that x square minus y square will be positive. Try to simplify this. The next graph is z equal to 1 upon square root x square plus y square and the second one is 1 upon x square plus y square. So in both the cases for any point x and y, x square plus y square will be non-zero except the origin, because if we choose the origin it will be 0. X square plus y square will be 0. So this both the functions will be not defined at the origin. So at the origin we are not getting any surface, elsewhere the function is well defined in the R2. So the domain of this function will be R2 minus a single point 0. So these are graphs for 1 upon x square minus y square and this function will be not defined if the denominator is 0. The denominator will be 0 if x square equal to y square. That means along the lines y equal to x and y equal to minus x. So see, there is no surface along this line y equal to x and y equal to minus x. The next graph is 1 upon xy. So the graph will be in 4 quadrant only. So there are 8 quadrant in 3-dimensional space, but this graph will be in 4 quadrant only. The denominator becomes 0 if xy is 0. So when xy will be 0 along x-axis, along y-axis. So there will not be any surface along this axis. Either of them is 0 or both of them are 0. We will not get any surface. So this is graph 1 upon x square plus y square. So this graph will be in the upper half 4 quadrants because z is positive for all the order pairs x comma y. And see, again the function will be not defined if the denominator is 0. X square into y square is 0. So x square into y square will be 0 if either of them is 0 or both of them are 0. So there should not be x-axis and y-axis in our domain. So the domain of function will be R2 minus x-axis and y-axis. The next one is are graphs for x square upon y and x square upon y square. So in both the cases, there will not be any surface when the denominator is 0. That means y is 0. That means along x-axis, because y is 0 along x-axis. So try to imagine the graph. The next functions are z equal to x cube minus y cube. It is algebraic function, polynomial function, so it is continuous everywhere. The next one is 1 upon x cube minus y cube. It will be not defined if the denominator becomes 0. Try to simplify when the denominator will be 0. The next one is 2 times xy upon x square plus y square and 2xy upon x square minus y square. In the first graph, the function will be not defined only at origin, because at origin it will be x square plus y square will be 0. Elsewhere the function is well defined. We are getting output everywhere except origin. So we will have the graph everywhere else except origin. So domain will be R2 minus origin. The next one is 2xy upon x square minus y square. So in this case, function will be not defined if denominator is 0. That means along y equal to x and along y equal to minus x. So see these graphs: z equal to e raised to x square plus y square, z equal to e raised to x square minus y square. So these are defined everywhere: x square plus 3y square into e raised to x minus x square minus y square. So the functions are defined everywhere. Z equal to e raised to minus x square minus y square and z equal to 7xy upon e raised to minus x square minus y square. So observe these surfaces. So next one is the surface for z equal to sin x. It is defined function for all points in R2. The next graph is z equal to sin x by y and sin y by x. See the graph. The next one, sin of x plus y and sin of y minus x minus y. Okay, so some part of the graph go below the xy plane, so that's why it is not looking there. The next is z equal to sin of x square plus y square. So this is beautiful graph, like a flower. Sin of x square plus y square. The next one is sin of x square minus y square. Visualize and try to find the domain. The next one is z equal to sin of 1 upon x square plus y square. The next one is sin x into cos y and sin x plus cos y. The functions are well defined on R2. Next is z equal to mod of x plus mod of y and z equal to mod of xy. So these are non-negative functions. So both the graphs will be along positive z-axis. The next is z equal to 1 upon 1 plus x square plus y square and z equal to sin hyperbolic x square plus y square. So observe A and B. Both are two different looks of the same graph: x square plus 3y square into e raised to minus x square minus y square. And next C and D. C is sin x plus sin y and D is sin x sin y upon x into y. The next are C. B is two different views of the graph of minus xy into e raised to minus x square minus y square, and in the left the level curves for this graph, this function. So level curves are curves, those are lifted to height z equal to k in the surface of f. And D is graph of the function minus 3y upon x square plus y square plus 1. And in the left, these are level curves for this function. So try yourself to draw the level curves. And the last one is f is 3 variable function from R3 to R defined by f equal to x square plus y square plus z square. So for fixed value of k, for k equal to 1, for k equal to 4 and for k equal to 9, I will get x square plus y square plus z square equal to 1, which will be sphere of radius 1. For k equal to 4, I will get x square plus y square plus z square equal to 4, which will be sphere of radius 2 centered at origin. And for k equal to 9, I will get x square plus y square plus z square equal to 9. That means it will be sphere centered at origin of radius 3. So these three are level surfaces of the 3 variable function f equal to x square plus y square plus z square. So the level curves for this function, graph of this function will be in 4-dimensional space. So I cannot draw graph in the 4-dimensional space. So I have to study the level surfaces of this 4-dimensional graph in R3. So the level surfaces are spheres in 3-dimensional space. So the level surfaces are this family of spheres centered at origin and of radius k. So we have seen some surfaces or a graph of 2 variable functions, their level curves, and some level surfaces for 3 variable functions. So you can try yourself to visualize the concept of graph or surfaces of 2 variable functions, their level curves, and can you imagine the graph in 4-dimensional space and their level surfaces in R3.